Welcome back. Today we are looking into non-right angle triangle. And so before we move on to the methods to solve for a right angle triangle, a non-right angle triangle, we need to look at the basics of it. So the basics of it is how to label a non-right angle triangle. So I've got 2 points here. So wherever your vertices/angles are, I'm going to label it with a capital letter. So this is an angle / a vertice or vertex. And I'm just going to label it as a capital A, B, and C. To find your sides, right? Same thing what we use for SOHCAHTOA. If this is my angle A, right? My side would be the opposite of it. Okay, so this will be side A, this will be side B, and this will be side C. Okay, sides correspond to the opposite angle, nothing new, right? We've learned this in SOHCAHTOA. So yeah, let's move on to the first example or the first method to solve a non-right angle triangle. So the sine rule here finds the sides/angles of a non-right angle triangle. For example, for SOHCAHTOA, right? SOHCAHTOA is used as a method to solve a right angle triangle. Sine rule is one of the methods to solve for a non-right angle triangle. So I've got the formulas here, right? The first formula right here is to solve for an unknown side. The second formula here at the bottom is to solve for an unknown angle, okay? Now I've labeled a triangle right beside it. To know when to use sine rule, right? What I want you to look for is a cross. So let's say I've got if I've got information for angle A, so let's say I know what angle A is, okay? I know what side length it is. I know what the side length for C is, but what I'm trying to find is angle C. So what I'm trying to look for to know that I need to use sine rule is I need to look for a cross, just like this, okay? So I've written down here, you need to look for a cross, okay? This will make more sense when we do an example of it. Again, shows that an angle affects the length of the opposite side, nothing new. Let's go to our example, okay? So our example here, we need to first look for a cross. So let's do that. Find a side. Let's look for a cross. I found my cross, therefore I need to use sine rule. All right, find a side. I want to find my unknown side as my first. So I'm going to write x over sine, the opposite angle for that side is 30. So x over sine 30 equals to the side of the next one, which is 13 over sine 50, right? My end goal is to have x equal to something, right? That's the side. So what I need to do now is how do I get from x over sine 30 to x equals 2? Well, I need to get rid of sine 30, right? I'm going to do that on both sides. I'm going to multiply it. These will cancel out. What I'm left with is x equals to 13 over sine 50 times sine 30. Okay, put that into your calculator and you should get 8.49 centimeters for x. Super easy. All right, let's do our second example here. Okay, find an angle. Okay, first off, to find which method I need to use, I need to see a cross. Let's do that. I see a cross here, so therefore I need to use sine rule. But this is now finding an angle. So what I need to use is my unknown angle, which is this one right here. I need to write sine theta over its opposite side, which is 14, equal to sine 60 all over 17. how do I get sine theta by itself? I need to multiply 14 on both sides. This will cancel out, right? I'm left with sine theta equals to sine 60 over 17 multiplied by 14. Okay, I need to get to what's theta equal to, right? What's the inverse of, or the opposite of sine, which is inverse sine, or sine dash 1, right? Theta equals to sine dash 1, sine 60, we're just going to copy this down, multiplied by 14, we'll wait for it to get there. Good, put that into your calculator and you should get, make sure you press your bubble button, right? Because we're looking for a degree, 45 degree, 39, 29 minutes and 44.39 seconds. Let's say I want to put this into the nearest minutes. Therefore, I've got 45 degrees and 30 minutes. Okay. And there you go. Okay. So let's now go on to our last example. Find an obtuse angle. So an obtuse angle needs to be greater than 90 but less than 180. Okay, so one important thing that we need to note is that an obtuse angle, right, to find it, I need to do 180 minus theta. Yeah. Okay, that's an important thing. Okay, we've identified that. Let's see if it makes a cross in our example. Yes, it does. Therefore, I need to use sine. I need to find an angle. So I need to start off with sine theta all over the opposite side, which is 22, equal to sine 13 over 12. Okay, same thing like what we did in the second example. I need to make sure sine theta equals to something. So I need to get rid of this 22. I'm going to multiply it on both sides. This will cancel out. I'm left with sine 13 over 12 multiplied by 22. Okay, how do I get theta by itself? Well, the inverse of sine is sine, inverse sine, or sine dash 1. I'm going to write this into here, right? Just copy it down. Put that into your calculator and you should get 24 degrees and 21 minutes. Right, we found the angle, but we need to find the obtuse angle. So I need to apply this. So theta, or let's say obtuse, right? The obtuse angle will equal to 180 minus theta, which is 24 degrees and 21 minutes. Put that into your calculator, making sure that we have the bubble button for this part here, right? And we should get 155 degrees as my obtuse angle. Hopefully that helps, and I'll see you later. Bye.